Hi friends, so this is the given problem. Find the equivalent capacitance in between X and Y. So this is the problem given to us. As these things are in capacitance, so we need to find the formula first. If two capacitors are in series, so the equivalent capacitance is, let me write in another manner. So the equivalent capacitance, so the equivalent capacitance 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Similarly, if two capacitors are in parallel, C1 and C2, so the C equivalent is equal to C1 plus C2. Now let us solve this problem. So this is the given problem. As we know, from X to Y, we feel that current is passing from X to Y. So as this current is flowing in this way, so once it has been divided into two parts, so this some current is flowing in this way and some current is flowing in this way, and after that this current is again divided into two parts, in this part and this part, and this current is flowing through this capacitance also. Again this current and this current, all the three currents are added here and it is flowing through this 2 microfarad capacitor and it is reaching Y. So now we can able to see here, first capacitance is 2 microfarad. Okay, so after that the current is divided into two parts. One current is passing through 1 microfarad and the second current is passing through 2 microfarad and 2 microfarad. So here we can easily identify that this capacitance and this capacitance are in series because same current is flowing through these two capacitors. So now I can write here C equivalent 1 is equal to, this is, these two are in series, so I need to write this formula. So let me write that formula. So 1 by C equivalent 1 here, 1 by C equivalent 1 is equal to 1 by 2 microfarad plus 1 by 2 microfarad, so which is equal to 2 by 2 microfarad. So this and this will get cancelled, which implies, so C equivalent 1 is equal to 1 microfarad. So this part is up to this. So now I can remove this part and I can draw it with only one circuit. So let me draw the circuit also. So please see here. So this is reduced into this part now. So this is the circuit now. So after reduction, so this capacitance is 2 microfarad and this capacitance is 1 microfarad, and now this capacitance is also 1 microfarad. This is 2 microfarad and this is 1 microfarad. So now also we need to see in the same manner. So let us see now. Current is flowing in this direction and it is dividing into two parts. So again it is dividing into two parts and again it is joining here in this way. So here one part of current, the current is added here and again it will be added here. So these two capacitors are in parallel. So now let me write C equivalent 2 is equal to, so this is the equation for capacitances in parallel. So C equivalent 2 is equal to C1. So C1 is 1 microfarad plus 1 microfarad, so which is equal to 2 microfarad. So now I can remove this part and I can simply write with 1. So let me move here only. Yeah, so this is simply like this. So now this value becomes 2 here. Now now if you can see, the current is flowing through this 2 microfarad and this 2 microfarad is same. So I can say that those two are in series. Now 1 by C equivalent 3 is equal to 1 by 2 microfarad plus 1 by 2 microfarad, which implies, obviously, which is equal to 2 by 2 microfarad. So 2 will get cancelled, which equal to C equivalent 3 is equal to 1 microfarad. That means now the circuit become like this. And this value is 1. Now this will be our circuit diagram. Yes, and this value is 1 now. Now you can see simply this 1 microfarad and this 1 microfarad are in parallel now. So let me write it as C equivalent 4 is equal to 1 microfarad plus 1 microfarad, which is equal to 2 microfarad. So now I can remove this part also. I mean I have reduced it, so I can remove this into equivalent capacitance. So the equivalent capacitance here is 2 microfarad. So let me write the same. So this is 2. Now this 2 microfarad and this 2 microfarad are in series. So we can say that final C equivalent is equal to, so this is 2 microfarad. So these two are in series, so I need to follow the first formula. So let me write that 1 by C equivalent is equal to, so 1 by 2 microfarad plus 1 by 2 microfarad is equal to 2 by 2 microfarad, which implies C equivalent is equal to 1 microfarad. So this is the final answer. So this problem especially shows how the series and parallel connections are identified, okay, and how the series equivalent capacitance is, obviously the derivation was already there in our videos. So this is simply the recollection of that derivation. Of course, for resistors and inductors, the if they are in series, equivalent resistance and equivalent inductance are simply addition of them. But if they are in parallel, so equivalent resistance and equivalent inductances are 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Similarly, 1 by L equivalent is equal to 1 by L1 plus 1 by L2. But coming to capacitors, it is simply reversed. That's all. Okay, so please try to identify. This problem is very easy problem, but a very important problem. So no need to get any confusion. So simply, if you can write the formula here, and if you are in a position to identify which two capacitors are in series and which two capacitors are in parallel, so it's very easy job for you to go ahead with it. Okay, thank you so much for your careful listening.